In this video, we will be looking at the symmetry of combined functions. So first of all, just a reminder, a function has even symmetry when f at x is equal to f at negative x, which just means if I reflect my function over the y-axis, the function will look the same. Whereas odd symmetry, f at x is equal to negative f at negative x, meaning it has rotational symmetry or a double reflection. So if I take my original function and reflect it over the x and the y axis, then it'll look the same. Okay, so when we're combining functions, if we have two even functions, if I add, subtract, multiply, or divide, it will result in an even function as well. If I have two odd functions, if I add or subtract it, then we'll still have an odd function, but if I multiply or divide, those two odd functions will result in an even function. If I have one of each, one even, one odd, if I add or subtract, in most cases, we will have a function that has neither symmetry, but if we multiply or divide, it will have odd symmetry. So let's look at 4 examples together. Okay. Actually, I will keep the table there for us to look at. So if I have sine x and x cubed and I'm going to add them, my first step is to figure out what kind of functions we have. Well, sine x, for this one, I'm just kind of thinking back to my reflection identity or just a little visual. Here's the sine x function. If I just reflect it over the y-axis, it'll result in this, which is not the same thing. So it's going to take a reflection over the x-axis to make them match, which means f at x is an odd function. And I'll just make a little note. Sine x equals negative sine of negative x. And x cubed, I can think about the visual, or I can do this algebraically. So if I have g of negative x, that's negative x all cubed, which is negative x cubed. That's not the same. But if I do negative g of negative x, I'm just adding a negative to what I just got, and that gives me the original function. So this is also odd symmetry. So now if I look at my table, two odd functions together, added, subtracted, will result in an odd function as well. There we are. Let's look at the next one. We have two functions that are going to get multiplied. I'm going to do this algebraically for both. The only time I like to do the visual is for sine and cos, like the trig functions. So we'll start with f at x, and I'm going to start with f of negative x. Now remember, for something like this, it's not a one-step wonder. I can't just distribute the 2 in. What I'm going to do, I'm going to factor out a negative from negative x plus 2. They're still both inside that bracket to the power of 2. And then I'll apply the exponent of 2 in afterwards. And when I apply the exponent of 2 into the negative, it'll just become a positive, and then we're just left with the exponent on top of these two brackets. And it matches with the original function. So this one was even. And if I look at g of x and I reflect over the y-axis, a negative, the bracket was in the wrong spot. When I have a negative to the power of 4, it will become positive. So this is even as well. So now we have two even functions. We are multiplying or dividing. So I am here, which means I will result in an even function as well. All right, let's go to the next one. We have cos x and x squared. Well, for cos x, I'm just going to do a little visual. Here's cos, and when it reflects over the y-axis, it's just a continuation. So this has even symmetry. And g of x is just a parabola. I'll show it algebraically though. A negative to the power of 2 is positive, so this is even as well. So we have two even functions being divided this time instead of multiplied, but that is still an even function. And last one, I have f at x. Let's evaluate f at negative x. So we'll have negative x plus 1, and negative x minus 1. Here we're going to have to factor out the negative 1 from each bracket. Okay, so when we're dividing out the negative 1, it does change the signs of the terms inside. And now I'm just going to look negative times negative times negative. That's still negative. So I'll just have the single negative out front. Oops. Oh, my apologies, that should be a 1, not a 2. All right, now when I compare, these are different. So now I will evaluate negative f at negative x. And when I put a negative in front, it will turn that negative x into a positive. And now we have the same function from the beginning, which means that double reflection gave us an odd function. And now x squared, we already proved in the previous example that it was even. So here I have an even and an odd function together that are being subtracted. So I look up top and we are right here. So our combined function is probably going to have neither type of symmetry. So remember, your first step is to see what kind of symmetry you have, like we did in previous lessons, especially for the polynomial and the trig functions. So check that out first, and then we can compare back to that chart to see what happens if I have two even, two odd, or one of each. And remember, when we're in this factored form for polynomials, you want to factor out the negative 1 coefficient, and then apply that outside exponent for the cleaning up. All right, now that we're done with symmetry, just a final little word problem to connect it to the combined functions. So an ice cream manufacturer charges $2 per ice cream. The revenue can be represented by r at x equals 2x. So revenue meaning the money coming in. Anytime someone buys an ice cream, they get $2, so 2 times x, where x is the number of ice cream bars being sold. The cost of this business includes rental space, ingredients, machines, salaries, etc. The cost can be represented by c of x equals 40,000 plus 0.3x. Determine a function to represent the profit of the business. Well, when we're talking about profit, it's money coming in minus all of the costs. So P of x, profit, is going to be revenue minus cost. So it's a subtraction of two functions. So 2x subtract, and because c of x is a binomial, I'm going to make sure to put brackets because this negative has to be distributed in. So just watch your signs. And then we can clean this up, collect our like terms, and here is my profit equation. And now I can answer any follow-up question I want. I just have to be careful. I have 3 separate functions here: profit, cost, and revenue. Make sure you use the correct one. How many ice cream bars need to be sold for the business to make a profit? So if I want to make a profit, I want to have a profit that is greater than 0. That means I'm making money. So I'm actually just going to be solving an inequality. So profit has to be greater than 0. So 1.7x minus 40,000, has to be greater than 0. This is just a linear inequality, so I'm going to bring the 40,000 over to the other side. And now I'm just going to divide both sides by 1.7. And I'm dividing by a positive, so I don't have to worry about any flipping of the inequality sign. So I get 23,529.4. I obviously can't sell 0.4 of an ice cream cone or bar, so I am going to round this up to 30, because if I were to round down like I normally would with a 0.4, you're going to be in the negatives when you sub it in, like a small loss. Okay, and there we go. This is how many ice cream bars you need to sell. Therefore, the business needs to sell 23,530 bars to make a profit. Sell to the bars. Sorry, actually, they need to sell 23,530 bars or more to make a profit. And there we have it, a mini application of combined functions.